And now we will have a plenary lecture by Dr. Junu Shrestha from the World Bank Group. He will talk about the World Bank, the science and technology innovation for sustainability. Please welcome him.
Good afternoon, everybody. I'm very glad to be amongst accomplished and distinguished participants here. I'm Junu Shrestha, Senior Environmental Specialist at the World Bank within the Environment, Natural Resources and Blue Economy Division. I'm glad to be sharing some of our experiences of using science and tech within our work in development. Thank you very much for the opportunity. I'll be stopping this video and then presenting on my work. Thanks. World Bank has two-pronged goals: to end poverty and to build shared prosperity. This is especially difficult in the world we live in because of all the challenges we have. For example, urbanization. Right now, over 56% of the world population is urban. So there's competition for resources, lots of infrastructure, and as you all know, the AR6 climate change report, the physical science basis, just came out that clearly showed that temperature has increased by about 1.07 degrees since the 1900s, and precipitation has likely increased, not to mention with a lot of changing patterns. So we live in difficult times, and we're living in pandemic. We're all living the consequences of it right now. So in addition to all this, we also suffer from lack of just plain data, reliable data. So in this world where there are so many challenges, science does provide hope. Technology does provide us with a path forward. Sorry. The bank has adopted something that we called GRID framework, Green, Resilient, Inclusive Development, as an approach for post-COVID recovery. GRID recognizes that the challenges of poverty, inequality, COVID-19, and the degradation of natural capital, including climate change, are interrelated. And it has to be addressed simultaneously and systematically. And as you can see, science and tech innovation are highlighted as cross-cutting enablers. We have a suite of technologies that are available that are making it easier for us to understand natural systems, their structure, function, and integrate such science into development work. Satellite technology for example, from satellite technologies to watershed monitoring and cloud computing. Smooth integration of such tech would make up-to-date information and science available for project design and implementation, making development work easier and more productive and more sustainable. Such tech is available and can be used for various sectors, from agriculture to forestry. And I'll go through some of the examples of our work in these sectors. In forestry, for example, Earth observations has really changed how we do things. A project here in Mozambique, Namibia, and Zambia uses EO tools to monitor forest degradation and deforestation, and uses cloud computing platforms to process data. Such practices have made, first of all, has generated data on dry forest, which has been very scarce in the past, and made it accessible, this data accessible to countries like developing countries like Mozambique, Namibia, and Zambia, and decision makers there. And this has allowed for the countries to participate in complex international schemes, forestry schemes like REDD+. Another example we have is the Brazilian Cerrado, where EO and geospatial tech has really advanced forest monitoring and management. PRODIS project uses Landsat to estimate deforestation annually. And combined with this, DETER was used to monitor real-time deforestation. This technology has made it easier to detect deforestation real-time and also help enforce laws against such activities. So this project also helped create this platform called DPAT, accessible to everybody, that freely provides deforestation data to public sector, private sector, academia, so that forestry data is transparent and available to all to make decisions. And for a biome like Amazonia, this is very vital. Moving from forest to the water to oceans, coastal development is a big part of our work. And we see that a lot is yet to be understood and explored about the oceans and coastal systems. And here definitely science can play a role. For example, just to name a few, climate change impacts on the ocean systems and coastal systems, integrating climate change projection in coastal and marine spatial planning. As we know, eventually oceans are the receptacle of all pollution. So R&D for emergent dispersion technologies, point sources of pollution, and also more recently, finding solution towards plastics pollution, finding substitutes. And fundamentally, understanding how ocean works, ocean dynamics is important. Modeling marine food web matrix, building ocean system understanding is necessary so that we can build better projects to protect them. A recent example of our involvement in ocean system and coastal systems is a project in the Caribbean. Countries here rely on coastal resources heavily, but data on coastal resources are scarce, making it very challenging to plan and finance their management. This project, CROP, undertook comprehensive ocean wealth mapping, laying out what is there in terms of natural resources, quantifying them, and developed an app so that decision makers have a clear knowledge on marine assets of their countries and work clearly towards planning for the sustainable use. Examples like these show how accessibility to data helps to integrate science into decision making. Moving on to now pollution. Pollution affects all land, air, and water. And as you can see from the diagram on the left, it causes death and diseases in many countries. And not only that, countries bear a high cost to their GDP due to pollution. Cost of environmental degradation studies that World Bank has conducted over the years in different countries have clearly demonstrated this. And a note on the graph on the right is Lao PDR, a country in the region that suffers a high loss in their GDP due to pollution. Bank is supporting countries to find solution to many issues of pollution as well. Air pollution being one of the most significant pollution issues. Here I bring example of Egypt. Air pollution has been a problem for Egypt for decades, particularly in large cities, capital city like Cairo. In Greater Cairo, level of particulate matter, PM10, PM2.5, is several times higher than the level that WHO recommends. So the quality of life and development work needs to really focus on reducing air pollution, so the quality of life in the city can be improved, right? So Egypt itself has developed one of the strongest air quality monitoring network. Over 90 monitors exist in the country. 45 of them are in the Greater Cairo area. And the bank has been working with the Ministry of Environment to complete a source apportionment analysis, really to figure out where this pollution is coming from, what are the sources, what are the policy measures that can be implemented, what options do we have to reduce such pollution. So doing such comprehensive analytical studies will help target the abatement process and really formulate effective policy measures. Next, we move on to the plastic problem. It's not new to us, especially for those in the region. EAP region is a big contributor to the plastic pollution in the oceans. The bank has supported ASEAN with development of regional action plan against marine litter, which just came out earlier in the year, showing the commitment of the countries towards the problem. And also from the national level, going all the way to local entrepreneur level, there are several entrepreneurs in the region that are working on finding solutions to this emerging big problem on plastics. They are working on finding better collection, segregation methods of the waste and plastic, and also alternatives to plastics, bioplastics, better compostable plastics. These innovators need to be identified. Their promising innovations need to be piloted and scaled up to match the issues at hand. And also, there's interest to scale this up, and investors are interested in matching up with these entrepreneurs, and the platform is needed to bring them together. And we're working on a project that is trying to do just that: identify innovators, help them pilot their promising innovations, and then pair them up with investors so that their innovations can be scaled up for impactful results across the region. Not only in our projects, like I just described, in different sectors, we're also integrating technology in our day-to-day work. We have to. Without that, there's no moving forward, right? First of all, to get field data and information, satellite imagery, drone services have been critical, especially nowadays where we can't do field visits. They've helped us track and understand what is happening on the ground on our projects. We are restricted to go to different countries, so we have reverted to virtual missions. We gather online and across different time zones and regions. And also after our meetings, which we call missions, our data information nowadays are more from a report, standard report format, to more interactive story maps, videos, and websites, so that it's readily available and easier to understand and absorb for ourselves and our team members as well. Here I'm showing an example of how bank uses public domain data to help project monitoring. This example shows high resolution satellite data visualization accessed through tools like Google Earth to monitor project. In this case, we have rehabilitation of Kamuju Barrage in Malawi. So As I started in the beginning, climate change data is very scarce, and bank has done something about it. We have something that we call Climate Change Knowledge Portal, a hub for climate change related information to be used worldwide and also for the bank internal projects. The CCKP, as we call it, contains climate change, disaster risk, and socioeconomic data sets all in one platform. This allows scientific data to be combined with economic and social data as we need in the development work. Not only discrete data like this, the CCKP also has synthesis products like climate risk country profiles that shows climate change risks to a certain sector like water, agriculture in different countries, along with historical climate change data, future climate projections for each country, consolidated using many climate models, reliable climate models. So making it more understandable, easier to digest for non-scientists. So another tool that we have developed within the bank is Spatial Agent. This really is data and information at your fingertips. It is a resource for economic ecosystems, functions, and demographic data. It's organized by thematic area, by country, by region. It is very rich. It pulls together data from sources like NASA, ESA, USGS, and makes it available for people like ourselves in the development so that we don't have to go to all these different websites, understand them. It's all in one, consolidated, standardized, and put together so that it's easier for non-scientists to use. And Spatial Agent, just to add, also allows for spatial and temporal manipulation, as some of our projects requires to see, how population evolves over time, or how deforestation or watersheds have changed over time. So next, we have tools, we have apps, we also do events, and we learn from our partners, like we recently did in the Green Tech event that featured how Korea brings innovation to address existing environmental challenges in forestry, in water management, and in pollution. Such events make experiences from countries like Korea available to development practitioners, private and public sectors, participants from all over the world. Hundreds of people participated, helping us improve awareness of innovative technologies that are available out there to address critical environmental challenges. And we hope through these events like these, practitioners apply such scientific solutions in their projects, in their countries. So finally, in closing, we all know we have a range of problems, and with science, we can understand them better, and developing such deep understanding of our issues, we can craft effective solutions. Science and tech are integral to all aspects of our work, and we seek new ways to learn from all levels, local, regional, and global, especially on 3 I's that we keep in mind: information analytics, institution and policies, and investment. All sides of it: preparation, implementation, and operations. As we see, we've been in development and also in science for some time. There's a need for science and development communities to work really closely together and bridge the gap that exists between research and application of the research results for the benefit of the most vulnerable. And I hope conferences like these bridge this gap and bring us closer so that we can address the sustainability issues more effectively and with scientific knowledge and tools. Thank you very much. Thank you very much for the opportunity, and we look forward to collaborating with you all in the future. Thank you.